so when we talked about projectile motion, we had these three formulas that we dealt with when we were dealing with stuff in the y direction. So key thing to remember in projectile motion is that the y direction and the x direction are independent of each other. So stuff in the x direction does not affect stuff in the y direction, okay, and vice versa. So this set of formulas is only good for the y direction. So again, these formulas are the dy equals 1/2 ayt squared plus viyt plus the initial distance in the y. Remember, we don't need that initial distance in the y except for like in situations where you shoot it up at an angle from a height of say 3 meters. So like when we did the hoop lab,
Bless you.
when we did the hoop lab, we shot it up and it was 1 meter off the ground already, so we had to take that into account. Acceleration of the y equals vfy minus viy divided by time, and vfy squared equals viy squared plus 2ad in the y. What is the acceleration in the y? What is it? Negative 10. So the acceleration of the y is also g, and it's negative 10 meters per second squared. It is important in projectile motion and in free fall that you make sure you know that you're putting it in as negative 10 meters per second squared. Okay? That's like the only time where you need to make sure it's negative 10. Any other time, you can usually just plug it in as 10 because you've already accounted for the direction either in your drawing or in some other way. Okay? But in this case, we do need to plug in as negative 10. In the x direction, there's only one formula, and that is vx equals dx over t. The reason x direction only has one formula is there will never be an acceleration in the x direction, okay? So you shouldn't have to worry about acceleration there. There were two types of projectile motion. The first type is if you just shot something off a cliff. Say this thing comes off a cliff at 5 meters per second. It comes off from some height h, all right, and you're trying to figure out stuff about it. Whenever things are shot off a cliff like this, if it's horizontal motion, at the start, the initial velocity in the y is what? 0. And so that's an important thing to note. The 5 meters per second is your velocity in the x, and you can usually use this height to find the time, because you know the initial velocity in the y is 0, so that's 0. Your starting point is here, so that's a 0 point, and then it's going to fall that dy, and so you can usually find the time it takes to fall. Right? So, for instance, if we were trying to find, I'm just going to plug this in, dy equals 1/2 ayt squared. Initial velocity in the y is 0, so we can leave that out. If you're trying to solve it, it would be 2 dy over ay square rooted. Okay? Hang on. Wilkins. Uh-huh. Yes. All right. Rachel, go to the AP's office. All right. So, square root of dy over ay would equal t in this case. All right. I'm not saying you should remember that formula. I'm just saying that's how you would find it for the most part. There was also the other type of projectile motion, and that's obviously when it's shot up at an angle. The first step to do when something is shot up at an angle is to break it into components. So it's vx equals v cosine theta, and viy, the initial velocity of the y, is equal to v sine theta. Some important things to know is at the top of the path, the velocity in the y is equal to 0. Okay? So at the very tip top, the velocity in the y is equal to 0. Also, when it gets back down to the point opposite, the velocity is the same. It's just in the opposite direction, right? It's an important thing to know. Also, remember that when you're trying to figure out the time to the top can always be found by doing the initial velocity in the y divided by the acceleration due to gravity. That's the time to the top. So for instance, if it had an initial velocity in the y of 30 meters per second, how long did it take to get to the top?
3 seconds.
3 seconds. Every single time you can figure it out that way. All right? It's a very quick and easy way to find it. Keep in mind also that if you're trying to find the height, you're going to use the time to the top. But if you're trying to figure out the distance total, you would use the distance in the x formula. So you'd have to use this formula right here. All right? Now, I should mention that on the formula chart, this formula, or like those specific formulas, don't exist. But that's just because we've modified them for projectile motion. They're the same formulas that we've gone over before, but they're new for projectile motion. Also, just in general, this v equals d over t doesn't show up because it's present here. So if we use the dy equals 1/2 ayt squared plus vi by t, if the acceleration of the y is 0, you'll notice that you're left with d equals vt. d equals vt is the same as this formula right here. So they don't show both formulas. So anybody got any questions about projectile motion? All right, last thing before we move on. If I shoot something off the table at 5 meters per second and drop something off the table, which one hits the ground first?
At the same time.
They hit it at the same time. Lovely. All right, good job.